Hello and welcome to this webinar. This webinar on automating NIST 800-171 compliance in AWS GovCloud with the NIST QuickStart tool. It's going to be about an hour long, and we're going to talk a lot about how to automate compliance in AWS. Before we get started, I wanted to talk to us briefly about why we should automate compliance. This is a topic that's been going on for some time that we have been trying to fix for a lot of customers for at least as long as I've been around at AWS for the last 3+ years. And a lot of folks, come to AWS and they come very quickly into the cloud, and they want to know very quickly how they can automate compliance. Why do they want to automate compliance? Well, a lot of it has to do with the way we've done compliance traditionally. Traditionally, compliance can be a very slow process for a lot of customers. It was in their traditional environments. And as they move over to AWS, the compliance burden is still there. And so they still need to take a decent amount of time to get their applications and their workloads into a compliant state and produce a lot of the documentation. Traditionally, we've seen that ATO processes can take anywhere from 6 or 9 months and cost in upwards of $100 to or even $250,000 worth of labor just to get it through an ATO process. And as we know, going into the cloud and moving into a very agile environment, this is not a desirable scenario. As we automate a lot of our systems, we need to automate a lot of the compliance as well. So this whole hour is going to be discussing some of the tools we've created here in AWS in order to help you not only automate the provisioning of systems through reference architectures, but self-document a lot of those systems in the same vernacular that your auditors want to see. And we're going to concentrate on the NIST 800-171 standard for this tool, but this also can apply to standard NIST or NIST moderate or even NIST high. The same set of tools we're going to describe today can help you meet a lot of the NIST-based requirements, regardless if it's a DoD or 800-171 or a DoD SRG type scenario. But today we're going to concentrate on 171. So what is NIST SP 800-171? Well, it's a new regulation that went in effect late last year, around November. This is a change in the way that the government wants their information to be handled by systems that are not owned by the government themselves. The DoD issued 2 rules that change the way that the DFARS requires DoD contractors to adequately secure and safeguard CUI information or controlled unclassified information on their systems that support the work being done on a DoD contract. And all this was spelled out in the NIST Special Publications 800-171. All the controls that are specified in this document are basically all of the confidentiality security controls at the moderate impact level from the NIST 853 catalog in order to achieve the objective of protecting unclassified but controlled information. So a lot of people are very interested in this specifically because they are either federal contractors, they're doing a lot of work for the government, or they could be researchers, or pretty much anyone that's dealing with government information and needs to protect it because this requirement was levied upon them, usually at the contract level. So what we're going to discuss today is how we can make that a little bit easier. We've created tools and a lot of automation that can help you meet a lot of the 800-171 controls in a repeatable and consistent manner. So that's what we're going to be talking about today. So what is CUI data, or controlled unclassified information? Well, it can pretty much be any type of federal information outside of a classified designation. Examples of this could be financial data. It could be a lot of restricted data or law enforcement data, immigration data, military records, patient data and records that were derived from the government, ITAR data, critical infrastructure. Pretty much any type of data that the government is going to provide a contractor could be considered controlled unclassified information. So what are some use cases? These are several use cases on this slide that are very typical for people using CUI data. One example could be a professor that's reviewing U.S. population health data for a federally funded research program at a U.S. university. This is in one situation where this 800-171 requirement would be levied. It could also be a systems integrator serving a government agency by updating a lot of their employee management system that includes government employee PII information to include, tax information. Or you could be a design engineer working on an aviation manufacturing hardware design in a CAD drawing. Anything that's provided by the government that's considered sensitive could be considered a CUI data. Another example could be a veterans hospital administrator managing blood type information housed by a hospital's electronic health records platforms. All of these are examples of government data that could be housed within a contractor facility and where these 800-171 requirements would apply. So the this is the AWS shared responsibility model. A lot of things we're going to talk about today are mostly within the blue area you see in this diagram. We're going to touch a little bit about, what AWS does to secure data at the infrastructure level for our services, but the majority of our conversation today is going to be around what the customer needs to do in order to protect data in the cloud, and by using a lot of the tools and artifacts that we can provide you in order to help you do this in a more confident and much more automated fashion than you're probably used to doing with previously. So a lot of customers have asked us, how many controls are there? How are they usually divided up? How do other large customers deal with compliance in the cloud? This pattern that I'm actually showing you right here is a very typical pattern we've seen in a lot of large enterprises when it comes to how the delegation of control responsibilities usually break out in a large organization. And if we go from the bottom up, you'll see that obviously the Amazon AWS actually takes care of a small percentage of controls. They all deal with the physical infrastructure, pretty much everything from the data center all the way up to the hypervisor in a lot of cases. But then we see a lot of customers that want to do cloud in a large organization typically have a provisioning team. These provisioning teams usually take care of setting the environments up, getting the accounts baseline, setting up all the basic security around a workload. And by doing so, they're going to meet a certain amount of security controls by setting up IAM, global configuration, logging, those types of things can all be taken care of by our provisioning team. And then, of course, the majority of the controls need to be satisfied by the workload owners themselves, anywhere from 70 to 90%. So as I said, if you want to look at this like a layered cake with all the different controls that you need to satisfy from a NIST perspective, you're kind of looking at AWS taking care of maybe 10% of the controls that are all around the MA and physical controls. Then you have some of the enterprise services taking care of 10 to 20, and this could once again be around configuring the accounts or setting up Active Directory or EPO services. A lot of those controls can be satisfied by a centralized provisioning team, and it's a typical pattern we see across a lot of our customers. But then once again, the workload owners, since they know their application, they have to secure their application. What we find is about 70 to 80% of the control requirements are at the application level, and those need to be done and documented appropriately by those owners. So what I'm going to show you today, and through a demonstration at the end, is how we have developed several standardized reference architectures that can quickly automate the provisioning of systems to be consistent with best practices. And why is this helpful? Because it allows you to kind of rinse and repeat. If you can automate a lot of your AWS infrastructures and you can do it over and over again, that saves you a lot of time and it does things through a very consistent manner. But one of the major reasons we're talking about this today around 800.171 is if you can use these reference architectures as a starting point, you can help meet a lot of the NIST requirements in a very repeatable way. And then you can take these reference architectures within your large organizations and pre-approve them for people to use within your organization. This provides a lot of flexibility in your workload owners to start from a known good starting point that has been pre-approved or pre-ATO'd by an organization, and it gives people a really good starting point before they start building in the cloud. These reference architectures help you to do so. So standardized reference architectures, another really big challenge they help out with a lot of organizations is there's a lot of decisions you can make when moving into the cloud. AWS has lots of different services and many different configurations you can do. But by creating these reference architectures, these standardized templates within an organization, you can cut down the amount of decisions that workload owners need to make in order for them to help moving into the cloud. And you can also make sure that when you have these templates that build these systems through automation, they can make sure that they're consistent and they have all the security best practices pre-baked in this baseline. And of course, by doing so, you can kind of pre-bake a lot of the controls these reference architectures can satisfy to make things go much faster from an automation, from a compliance perspective. And then one of the biggest challenges we see in why people move to these standardized reference architectures and mapping them, kind of pre-mapping the services that are going to be used in these architectures, is it cuts down on the amount of time it takes to map security controls to numerous AWS services. Is if you can do this through an automated fashion, there's a lot of things you can do in order to pre-bake a lot of the security in AWS GovCloud or other services that are being used there. So instead of having all the workload owners figure out all of these controls and best practices, if the organization can bake all of these into a library of templates, think about the time savings you can do by automating the provisioning of a system and then automatically pre-documenting a lot of the security and compliance requirements in a format that the auditors, the authorizing officials want to see as you go into the AWS cloud. The other thing that we find that if you can use these standardized reference architectures in order to deploy your systems through an automated fashion, it really cuts down on the error-prone and time-consuming manual configuration of AWS services. And by using these templates, or we're going to talk a little about today about these CloudFormation templates, by automating infrastructure as code, you're reducing a lot of the human error. By people going into the interface and doing things in a very haphazard manner, you're reducing a lot of that by replacing that human interaction with templates that can be used over and over again in a very consistent and repeatable fashion. Another really good benefit that standardized reference architectures can be used in a large organization is you can force configuration management. Since you're repeating the automation over and over again in a large organizations by templatizing these environments, you're actually implementing a really good configuration management system where you can take these templates and you can check them into your version control systems in order to automate the CM process around systems that are being deployed in the cloud. So if you ever have problems with a system, you can go back to the templates and fix them or debug them, and then check them back into your CM system and then redeploy them over time. It gives you a really good baseline that can be tracked accordingly as a system goes through its life cycle, if you can do this through a very automated and repeatable fashion. And once again, one of the main reasons you're probably listening to me today is the authorization process is very time consuming. If we can reduce this by making architectures that are repeatable in templates and that are pre-documented from a control perspective, you can really cut down on the amount of time it takes to go through the authorization effort. So every time a new system is built, you don't have to treat it like a snowflake. Since it's been pre-approved and the templates have been pre-approved, the testers and the ISSEs and the ISSOs don't have to look at every system independently if they know it's gone from a known good state. So this really helps out in reducing the time it takes to engineer, build, and document compliance controls in a very consistent way. So how do we do this in AWS? Well, we wanted to do a lot of the work for our customers. If we could make a reference architecture that incorporates all of the best practices and that we could create these templates for, so you could basically have a one-click deployment, we would take it to the next level by pre-documenting all the controls that can be satisfied using those templates. And that would be a really good place that customers could go and download these templates and then use them for their own baselines, and they can modify them. But the whole idea is if we can create the automation and then document them appropriately from a NIST perspective, it should really help customers go much faster without having to do that a lot themselves. Our reference architectures are actually kept as AWS QuickStarts, and I'm going to show you this in just a few moments. But all of our QuickStarts that have to do with compliance are on our QuickStart site. If you go to aws.amazon.com/quickstart, you'll get access to all of the compliant QuickStarts. Now we have a NIST compliant QuickStart, which is the one we're going to talk about today, that helps you meet 800-171 in AWS GovCloud. But we also have other ones out there for PCI and NIST High and so on and so forth. And as we create more of these over time based on customer demand, they'll be accessible on our website. But I'll show you more as we go through the demo at the end of this presentation. When you go to the QuickStart site, this is what it actually looks like. You'll notice that there's different quick starts you can actually click on in order to create a standardized architecture in your account. The one we're going to talk about today is NIST, and it's the one that's going to be, the demo at the end is going to be revolving around. You'll notice when you click on our NIST compliance, you can actually deploy from a button where it'll actually take the templates that we've created for you and deploy them and create a fully functional, production-ready, and compliant AWS architecture in your account. Or you can download the security control matrix that goes along with that reference architecture, so you can demonstrate how that controls are actually met from a NIST perspective. And we also give you a deployment guide, and I'll talk a little bit about more of those in detail at this time. So the four major pieces you'll find when you go to our quick starts are an architecture diagram, a security control matrix, and this is probably the most important part for these quick starts. It actually demonstrates and documents how the configurations that we've built through automation help you meet a lot of the NIST 800-171 controls in a manner that can be consumed by your authorizing official or brought into your SSP, or even brought into a tool like Telos Exacta in order to automate all of these controls as you're building systems through an automated fashion inside of AWS. Obviously, it still includes the CloudFormation templates themselves. These templates are available on our public GitHub site, but you can also download them directly from the QuickStart. Uh, and then lastly, the deployment guide. The deployment guide will kind of tell you and walk you through the requirements for using this QuickStart in your account. So these reference architecture, these QuickStart, what do they actually build? Well, what they're going to build when you actually click on them, and I'll show you this later on the demo, it'll actually build a fully functional, production-ready, three-tiered architecture that's highly redundant and available, and it's built through CloudFormation scripts that I will demo in just a few minutes. What you'll find that it builds an architecture that's very consistent to best practices. In this case, it's going to build a management VPC and a production VPC. A management VPC would be used for all of your Active Directory, your EPO, all of your security services that you know are going to stay pretty static no matter how many applications you have would go into the management VPC. The production VPC is actually where the entire three-tiered web app, which is the use case that we built this QuickStart for, is actually deployed in real time. In this case, it's going to deploy some proxy servers that are highly redundant across availability zones as the first tier. The second tier would be proxy servers, which are going to handle all of the calls and for the WordPress site that we use as an example application in this reference architecture. And then, of course, it's going to stand up an RDS database. That RDS database is what's going to hold all your data for these reference architecture. By using these quick starts and deploying these reference architectures into your account, here are some examples of some of the security features that are standard and turned on by default. I'll go over just a few of these just to give you an idea of some of the things that these reference architectures actually do to make sure it's as secure as we can possibly make it throughout this deployment process. So for example, we set up elastic load balancers that are automatically configured to support HTTPS and high availability. We set up network ACLs associated to multiple subnets that can allow and deny ingress and egress traffic. We set up private subnets that are not available from the internet. We set up S3 buckets, which are going to force SSL and encryption at rest. All of these are different types of security configurations that are done through these standardized reference architectures in order to ensure that you can automate the provisioning of systems. And then later we're going to talk about how we document NIST controls in a standardized format that can show how these controls actually map to the various NIST security requirements. The security control matrix is probably what most people use the most in these quick starts. These are free. They can be downloaded directly from our quick start, and this shows how all of the different configurations that we've done through automation actually map to the different NIST controls. This is very handy. It saves a lot of time, so you don't have to go through all of the different components and map them yourselves. We've done the mapping for you to make it a much easier transition into going from dev and test into production, where you need to get this data and present it to your authorizing official so they feel confident that you are meeting all of the NIST controls that are relevant to your system. The security controls matrix. This is actually this is a very large matrix. I'm going to show you it later, but it allows you to slice and dice all of the NIST controls in any way you see fit. This top portion over here allows you to look at all of the different controls from a NIST perspective and sort them based on what you care about. We have several columns, so you can sort by the CNSSI, control selection criteria, or the FedRAMP, or the SRG, and of course the 800-171 controls. So you can easily sort by the third party, the controls that are relevant to you so you can see how things are being met at the infrastructure layer. And down here, we're going to show you, and I'm going to explain this a little bit more, the CloudFormation template mapping. This is very important because we are using multiple CloudFormation templates to build the system. We actually map which one of those CloudFormation scripts is responsible for creating the resource that that control actually meets. So for instance, if you were to look across one of these rows, like AU12 or so on and so forth, you're going to see columns to the right which demonstrate which one of the templates is responsible for meeting that control. And you can see for the logging template, this control it's talking about, creates different buckets and bucket policies in CloudTrail, and that is actually responsible for meeting the control that's described to the left of this template mapping. This is very important. So if you ever want to know exactly which configuration is actually responsible for a certain control, you can really use this template mapping to do just that. And also one of the key use cases for using this matrix is not actually what you would think it is. Some customers have come to us and say, you know, we've already built our AWS environment. We don't really need the CloudFormation scripts, but we really want to use your SCM as kind of a validation tool to make sure we built ours correctly. So what they can do is actually take our spreadsheet and actually compare it to their spreadsheet to make sure that the statements that they created on how a control is met is consistent with what AWS says. We found out this is a very common use case for validating a system that's already been built and making sure that you feel confident in the statements you created are consistent with what is provided by these quick starts. So we're going to talk a little bit about CloudFormation, and the demo I'm going to go through in a couple minutes will actually demonstrate it. All of the quick starts are CloudFormation stacks. These are templates that describe how a system is actually created, and those templates actually create stacks. Each portion of the architecture that's created is created in a different stack. This is important so you can use these templates as building blocks. In some cases, you may want to customize one of the templates or delete one of the templates or completely replace one of the templates. By creating these different modules that are linked, we call them nested templates, it enables you to use these as the foundations for any systems to make it easier for you to modify them for your own use cases. It'll become more obvious throughout the demo at the end. So how does this CloudFormation work? If you're not familiar with it, it does do infrastructure as code, as I talked about previously. All the templates are going to describe the way a system is actually created. And the way that we created these quick starts, as I said, it was very modular. We have a main template, which is going to call a bunch of other templates. Think of a main template like a main function in C. And that main function in C is actually responsible for calling the rest of the components, which will build the system from the ground up. So in this case, the main stack will actually call the IAM stack, which will do all of the roles and permissions to make sure you have a good policy of least privilege set up. Then it calls the logging stack, and the logging stack sets up all of the logging for the account, and it turns on all the CloudWatch logs and the CloudTrail and so on and so forth. After that, it sets up the production VPC stack. If you remember from the diagram, we had two VPCs are actually set up, the production VPC stack, and then the management VPC stack. These are all different stacks that you can use for your own needs. In some cases, you may not want to use the production VPC stack, and that's perfectly okay. Utilizing this framework, you can just not call the management VPC stack and only call one. It's really up to your discretion in which stacks you use and which ones you don't. So at this point, after the management VPC stack, you're going to see the config rules stack runs. The config rules stack is actually going to do a lot of continuous monitoring in your account to making things that are very consistent and MFA is enabled and some other config rules that we actually have built as a sample rule stack to make sure that things are being done in a consistent manner in an account. And then we have the NAT stack. The NAT stack is important because, as I said earlier, that we are creating private subnets that need to talk to the outside world. In order to do that, if they need to get out for patching, so on and so forth, we create a NAT instance, and that NAT instance is in our public subnet and allows the private subnets to be able to get out to the internet. And then, of course, our application stack. In our particular example, we're setting up a complete WordPress application just to demonstrate a fully functional system riding on top of a secure infrastructure. In your cases, and the way you're going to use this, obviously you're not going to use WordPress. What you could do is just replace this stack with your own stacks. If you have the Windows app, you could replace it with the Windows stack or a Linux stack, whatever that may be. You just replace the stack, and you can use all of the other components to build an environment that's consistent to best practices. And at the end of the day, you get a fully functional VPC. The deployment guide, as I said earlier, is going to show you how to set up the environments. It's going to talk a lot about the prerequisites in your account that you need to be cognizant when you actually deploy a QuickStart, so on and so forth. Now, a lot of folks have asked around 800.171, how many of those are confidentiality requirements. Remember, I said that the 800.171 requirements is pretty much the moderate confidentiality controls. So we broke it down so people could understand better how many controls that actually is. Now, you may notice that our spreadsheet, when you download it, we actually have 1,700 controls. The reason that we have so many controls down there is because we broke each control and each subcomponent into its own row. So for instance, if it's an AU4, it could have a lot of subcontrols. It could have a part A, a part B, a part C, a part D, a part E. We decided, so you could be very granular in what you could do and what you couldn't do, is we took all of those controls and created rows for each one of those subcontrols. So at the end of the day, you'll notice that our 853 spreadsheet has 1,700 controls in that spreadsheet. And based on that, you can sort by this yourself. Around 736 of those controls are the moderate confidentiality controls. Now, out of that 736 controls, which ones can you get from AWS and which ones do you kind of need to do? Well, AWS can provide you obviously around 84 controls from our FedRAMP ATO packages, and these are all rough numbers depending on how you look at it. And then you can get another 50 controls from this QuickStart architecture. Remember, as I said, the automation will create an AWS architecture that meets best practices. You can get around 51 controls. But there's certain things you have to do. As you can see from this slide, about 400 controls are actually organizational controls or non-technical controls. These are controls that you may have to document on how you do personnel management or personnel screening or how your vulnerability management actually works. They're things that aren't truly technical that you have to provide documentation on you satisfy. We can't do this from the infrastructure layer. These are all organization or non-technical controls. So you can see there's a lot of controls there that have to be done at the organization level that have nothing to do with technology at all. So that's one thing to be cognizant of when you're talking about 800.171. There's lots of things you cannot do from a technical perspective. And there's also application level technical controls that we can't satisfy at the infrastructure. There's certain things that are done at the application layer and how you're doing authentication and auditing at the application layer that we're not going to be able to satisfy either. So those types of things are things that either your workload owner needs to document or the organization needs to define on how you meet certain non-technical controls. But if you take the controls that AWS provides, the organizational controls that you're going to have to document on either an organization level or a per workload level, you put that together and you can create a lot of automation around it so you can easily produce these things over and over again for all of those different workloads that are going into the cloud. Another pattern we find that how customers use these quick starts is they sometimes only use one or two of the quick starts. We have seen a lot of customers or provisioning team, back to that example, only use like one or two of those CloudFormation scripts. In this example, the provisioning team sets up all the IEM, it sets up all the security and the baselines for a particular account. And it also sets up all the networking and the IP addresses and the route tables. But at that point, it then turns it over to the workload owners so they can work within a consistent environment. This is a good example of not using all of the stacks. They're only using two of the stacks, but it helps them make sure they consistently meet a lot of the security and compliance requirements as accounts are being provisioned in the cloud. Once again, this is just one example of one pattern we've seen that's very popular, but a lot of organizations want to go higher. They want to do more for the workload owners, and it's really up to each organization to figure out how far you want to go up the stack and how prescriptive you want to be with it for your security in GovCloud or in your organization. So at this point, what I was going to do is actually go through a quick demo of how this all works. So I'm going to go ahead and show you my screen, and then I'll walk you through kind of how you actually use these quick starts and demonstrate on how a secure infrastructure can be built in your account in about 30 minutes. All right. So if you look at my screen here, if you navigate to aws.amazon.com/quickstart, you're gonna see the different quick starts around security and compliance. And the one we're gonna discuss today, or demo, is the NIST reference architecture. If you click on View Guide, it'll bring you to the deployment guide. Remember I talked a little bit about this previously. This gives you all the information and the prerequisites it takes to use these NIST quick starts and make them functional in your accounts. From this page, you can actually click on all of the templates and download them to your desktop, or you can go ahead and just launch them directly into your account. So what I'm going to do is I'm going to launch them, but you'll notice in a few minutes I'm also going to download the SCM. Remember that SCM that I referred to, the security control matrix, will be downloaded once you click this link. And you can use this as a basis on how you just can describe on how this secure reference architecture that you're going to use and modify meets a lot of the NIST 800-171 controls. So for this demo, we're going to go ahead and click Launch Quick Start. Once you click Launch Quick Start, it's immediately going to log you into your AWS account. In this case, I was already logged in, so it didn't have me authenticate. But it's going to pre-populate the S3 link with the template that's going to start the building process. And as I said earlier, the main template is the one that is going to kick off the build process and call a lot of the other templates. So I'm going to actually build this in. Let's go ahead and build this in North California. Hit next. And this will kind of demonstrate what it takes. So what just happened here is it downloaded the main template, and then it's prompting me for certain parameters to tailor this environment for my particular workload. I have to add a database password because obviously this is specific to the RDS database it's going to build. I can actually put a email address in here. This will where the notification email address will be sent for security relevant events, because a lot of the CloudWatch logs and alerts are going to alert you when security relevant changes happen. You can put your email address in here. You're going to choose an SSH key that is going to be injected into your instances. Remember, this builds a fully functional WordPress site, a 3-tiered web app. So it's going to create a bastion host. It's also going to create a web servers and proxy servers, and you can choose which SSH key is actually injected into those instances at this page. You can also choose if you want to use the config rules. Not all of our regions support AWS config rules, so you can choose if you want to use them or not, depending on the region that you're currently running in. If you choose yes, it's automatically going to put those config rules in your account. But if you choose no, obviously it's going to bypass that. That's going to be all dependent on which region you're choosing within AWS. You can also choose the availability zones you want to deploy into. As I said, this is going to deploy a fully functional WordPress site that is spanned across multiple availability zones for highly available requirements. In this case, we picked 1B and 1C to deploy into. And at that point, you can just go ahead and click Next. You can put tags here if you want to tag all the instances and resources, but for this demonstration, we're just going to hit Next. And you're going to click that it's going to create IAM resources with custom names, because I remember it's going to set up a policy of least privilege in IAM with roles and groups that are consistent to a lot of the requirements that are stated within the NIST 800-171 requirements. At that point, you're going to hit the Create button. And at that point, if you hit the refresh button, it's going to start building. And as I said earlier, remember, these are built with building blocks in mind. So the main stack is going to call the other stack. So what you're seeing here that's actually building here is first the main stack is being pulled in, and then it's going to start pulling in the other stacks, which are going to build portions of the environment. So in this situation, it's creating the production VPC stack, it's creating the IAM stack, it's causing the logging stack, so on and so forth. So as it builds in about 30 minutes, it's going to build a fully functional WordPress app sitting on a production-ready infrastructure in AWS. Now, since it does take about 30 minutes to build, I'm not going to sit here and have you wait for it. It's going to be like a cooking show. I'm going to put something in the oven and then go to one that's already been completed to kind of show you what the end product is, just to save time. So if I go back to Ohio or US East 2, I should have one already built for you so we can look at it briefly. And this is actually what it looks like at the end. We have our main stack here, and then we have our different stacks which it built a whole environment for. The IAM stack, the logging stack, the production VPC stack, the management VPC stack, and the application VPC stack. Now, most people will not use this application stack because you're probably using your own stack. This is just for demonstration purposes. But to make sure it actually works, we actually put a landing page on the WordPress site to make sure that you can actually see that it works in real time. So the way you can actually get to the URL to the application server, which is hosting this landing page, is actually go to the application template, click on Outputs, and you're going to see a key called landing page URL. This is a URL to the app server that is hosting the WordPress site. So if you click on it, you're going to notice that here is the congratulations page, which states that you are now looking at an app server which is within one of the availability zones that is helping this application function properly. From this page, you can actually download the security control matrix or even talk to AWS professional services. It just kind of shows you that everything was built correctly. Now, if you want to, you can actually go into all of the different consoles and actually examine what was actually built. In this case, we can go back to, say, EC2 and actually see what actually was built here. As you can see, when we go into EC2, you're going to see proxy servers, which is the first tier of the three-tiered web app. You're going to see app servers, and you're going to see a Bastion server. The Bastion server resides within the management VPC, and the proxy and the app servers are going to be within their various subnets. You notice there's two of them because they are distributed. One is within one of the availability zones, and that should be obvious when you look at the availability zone it's in. So for example, one proxy server is in US East 2A and the other one is in 2B. So this demonstrates how these instances are distributed to create a highly available website, WordPress site as an example application. You could also go in and look at, you can also look at VPC. Go in and actually look at the VPCs that are created by clicking on VPC. And within VPC, you notice that there are now two VPCs that were created by this QuickStart, the production VPC and the management VPC. So this kind of demonstrates and shows you what was actually built when you created that CloudFormation scripts and you actually execute them within your account. Now, what I wanted to do was quickly show you, now that we showed you how the actual templates are executed, I wanted to show you what the spreadsheet actually looks like when you download it from our QuickStart site. You will notice that this is a very large spreadsheet, and it can be used as a Swiss Army knife of sorts in order to help compliance folks get to the information they need in order to generate an SSP or something along those lines. You'll see all of the NIST controls that are down the left here. As I said, there's 1,700 lines in this spreadsheet because we broke out each one of the sub-controls into its own row. But if you scroll to the right here, you're going to notice a very relevant column here called the NIST 800-171 column. And this is where we actually did a lot of the mapping for you that's contained within the PDF that you can get from the NIST site. But this actually maps all of the 800-171 requirements to the various controls. And this is very helpful. If you want to know how this architecture helps you meet all these individual controls, you can actually sort by all of the different controls, or for my case, I actually took out the blanks, so I'm only looking at the various 800-171 controls in order to help me answer basic questions about how a control is met at the infrastructure layer. But you can sort by any of these columns, which this becomes a very useful tool into looking at an infrastructure from different viewpoints, either from the CNSSI viewpoint, the FedRAMP viewpoint, the DoD SRG viewpoint, so on and so forth. The other thing I did want to mention was this is to the left on this spreadsheet is the CloudFormation template mapping. This actually, for each one of the controls that we can satisfy, we document which resources are responsible for that control. So if you look at this control, the one I'm looking at is AC2, you can see that the logging stack was responsible for creating these resources around CloudTrails and alarms. And if you want to go look into how that control is met using these resources, you can go into this specific template and look for these resource names in order to really understand how that control is met and how it's configured within that particular template. All right, so what I'm going to do now that I went through that, I'm going to go back quickly to our presentation. And we'll go ahead and finish up quickly. So what we did here is we talked about the templates, we talked about the quick starts, we also talked a lot about the compliance requirements that are documented in the spreadsheet. But where do you go from here? Well, what would you like? We encourage you to do is go try out these templates. Go deploy them in your account. Take a look at the spreadsheet and how those different 800-171 controls are being satisfied. And then take our templates and start modifying for your particular workloads. Use our spreadsheet, use our templates as a starting point. It'll really help you understand not only how to build a secure architecture based on best practices, but it also will show you how those different configurations map to the different controls that are relevant to you. Use those as a starting point, modify them to your own needs, and then make them available in your organization. Encourage folks to use them as a starting point so they're not starting from scratch and they can feel confident that things are done in a secure and compliant manner. But a lot of questions will probably come up along the way about how do I get more help? I need help either modifying these CloudFormation templates, or I need help modifying the controls matrix to my particular needs. We have several different methods for you to get more help if you need so. We've just developed a AWS compliant jumpstart program. If you're interested, where you can bring in AWS ProServe into your organization, and they can help you modify these templates and modify those SCMs to meet your particular workloads. We encourage you to look to your account manager for more information if you are interested in this type of engagement. Some of these engagements include doing high-level analysis, design, and planning around compliance and your workloads. We will come to your organization and help work with a lot of your CISOs and your stakeholders and your developers to help you create these templates that are very specific to your workload so you can use these to deploy applications over and over again in a very repeatable manner. We'll help around education, workshops, so on and so forth. If you're interested, I please encourage you to go ahead and talk to your account manager for more information. Once again, all of the resources that I talked about today are in our QuickStart website. I encourage you to go download them, take a look at them, and modify them to your own use cases. I hope that this webinar was useful for you. If you have any questions, you can contact me. My email address is brettmi@amazon.com. I'll do my best to answer any questions you may have. But at this point, I think the webinar, we're going to head and once